Yeah, recording is started. Okay. So I will just repeat a bit. So basically, DS here means the change in the stock price in time dt. Okay. So that is what they have written. And what we are doing is we are basically doing the Euler discretization, and this discretization basically help us to visualize the model. So you can basically plot this on Python, right? Once you discretize the model, and this also helps you to in the method of moment. Okay, so this also helps you in the method of least square that you can explore. So basically now this dwt, so this is basically normal distribution, right? So basically you can write it as root under dt into z, where z is a normally distributed thing, so with mean 0 and variance 1. Earlier it was having a mean of 0 and variance of dt. Okay, so now once we have converted it into something like this, but it is easy for us to, deal with the return part. So that is, what is the return? So return is basically st plus 1 divided by st. Okay, got it? So yeah, if I have skewed this part. So this part is quite easy. Okay, so what they have done here is, uh, so basically once this part, this thing, just a minute. This is the drift part, okay? So mu is the drift. So whenever you discuss SD, that is a stochastic differential equation, this is the drift part, okay? So here the drift part is taken as RST, okay? So when you see geometric Brownian motion, I hope you know what is geometric Brownian motion, right? So the Heston model assumes that the stock price follows the geometrical Brownian motion. I hope you all know. So this is the assumption of Black-Scholes as well, that the stock price follows geometric Brownian motion. So that is why they have written the drift term as RST, and they have written the volatility term as root under VT into ST. Okay, nothing else. And now this DT, so this is the time step. So how much time step you are changing? So basically now we have assumed that we are continuously moving up one time step upward. That is why we have written DT as 1. So basically DT here is 1, and then everything is equal. So now we will be dividing the both side by ST. Why? Because we want to deal with the return part. Okay. So this is the expression for return. Okay. So QT plus 1 is the return. So basically ST plus, so QT plus 1 is given by ST plus 1 divided by ST. This equation. Okay. Now, now we go to method of moment. Method of moment is, so we already discussed, I shared some material as well. So moment is nothing but nth moment. Whenever we define nth moment is defined as the expected value of, so nth moment of x will be expectation of x to the power n. Okay. So for example, nth moment of qt plus 1 will be expectation of q to the power n. Okay. So here they have written jth moment. So jth moment of qt plus 1 is expectation of qt plus 1 into j. Now you know how to calculate expectation, right? Expectation of something is equal to, can anyone in the meeting tell how to calculate expectation of a random variable? Anyone in the meeting? How to calculate expectation of a random variable?
Summation
Anyone?
of PIXI,
Summation of?
the probabilities and basically that particular number PIXI.
Yeah, very good. So it is basically xi into pi. Okay. So the probability, so we have basically summing up all the possible values of xi with their probability pi. Okay. So for example, if it is dice throw, what are the possibilities of x? It is 1, 2, 3, 4, 5, 6, right? And then what is the probability of all these random variables, all these random values? The probability is 1 by 6, right? So how do we calculate the expectation of x? The expectation of x will be calculated by xi into pi and summation over all I. So it will be 1 into 1 by 6 plus 2 into 1 by 6 plus 3 into 1 by 6. That will be the expectation of x. Similarly, in this case, the expectation of q, which q is basically return. So basically, we are calculating the expectation of q to the power j. Okay. So basically, the jth moment, as we already discussed, the jth moment is defined as expectation of q to the power j. Similarly, the nth moment of x will be defined as expectation of x to the power n. Okay. So now what we are doing, so this mu1 is the first moment of Q, okay? This mu2 is the second moment of Q. This mu4 is the fourth moment of Q, and mu5 is the fifth moment of Q, okay? So see, we already have the data of return, okay? So we already have data of historical return. From there, we can calculate the moment. So we know mu1, we know mu2, we know mu4, we know mu5. From there, now also, once this is the numerical form of, so we are not using this is the numerical so expressional form of qt1, okay? So from here also you can calculate the moment, okay? So let me show it to you how are they calculating the moment, okay? See, expectation of q to the, so this is the first moment of q, okay? So how they are calculating, so it is basically expectation of q. What is q? Q was 1 plus r plus root under this, right? Got it? And then its probability. So this is basically 1 plus r. Similarly, we are calculating the expectation of q square. So expectation of q square. This is basically the second moment of q. Similarly, we are calculating the third moment. This is the expressional form. But we can get this value. So just a minute. So this is the, we know what is mu1, but we also know what is the value of 1 plus r. So we know mu1, that means we know what is the value of 1 plus r. So from here we can get r. R is our risk-free rate of return. We know mu2. How do we get mu2? Mu2 is the second moment of q, right? So once we know mu2, we know what is the value of r plus 1 square plus theta. We already know the value of r. So from here we know the value of theta. Similarly, from these two equation, we get to know the value of k. And what is the fourth equation? What is the fourth parameter? R, theta, k, and sigma. Okay. So r, theta, k, and sigma, we get it from here. Now you may ask, why didn't we calculate the third moment? So here they have provided the region. uh, in the third moment, so when you calculate the third moment, this row does not appear. So there is no point in using the third moment, right? So basically, there are four value, four uh, you know uh, unknowns, and we have four equations. So that is why we have to solve this equation. Rho does not appear anywhere else, so there is no point in writing the fifth moment, or there is no point in writing the sixth moment. So when you calculate the sixth moment, seventh moment, eighth moment, you won't get rho anywhere. So the only solution you have is to estimate the value of rho. Okay. So let us discuss the code for this part. So this part is used for calibration. So from here you can get the value of r, k, theta, and sigma. So this is calculated from the historical. Let us see how do we do it. Okay, then you will understand. So just a minute. Yeah. So basically, first of all, we download the historical data of Apple stock. Okay, so we have used 10 year of data. Okay, we have removed all other irrelevant column. Okay, and we have used close. Okay, so basically we have used close price as the stock price. So we have replaced close price with S. So this was our ST. Okay, so this is our ST. Now, from how do we calculate Q? So basically, see this formula. So basically, we are calculating Q as S divided by, we are shifting S by 1. So it will be nothing but how, and then here we are dropping one column. So the first column will be dropped. Okay. So if I don't drop it, let me show it how will historical data will look like. Just a minute. So everyone understand how we calculating Q, right? So basically this Q is calculated by dividing this data with the earlier data. So the current stock price divided by the earlier stock price. So this is basically Q over this time. Similarly, this Q is calculated by dividing this stock price. So this current stock price with the past stock price. So basically we are shifting by one. So you know how to shift by one. So if you are familiar with Python. So basically this is the current stock price, and this is the stock price of 1 day back. So by using dot shift, so basically you are shifting by 1 day. Okay. Now for the first date, that is for 16th, we won't get any Q, right? Because for 16th, we won't have any data one day back. So we won't be able to divide by something, right? So that is why we have dropped that column. We have dropped that row. So drop any is used to drop that row. Okay. Now, so this Q is basically a data frame. Okay. Pandas data frame. You know what is Pandas data frame. So we have converted into an array. Okay. Now, once we have calculated, so after converting it into array, it is simpler. It is very easy to us for us to get the for 5 moment. Okay. So this is the first moment. So basically, you can see this is basically for I in range 0 to 5. So basically, I is moving from 0 to 4. So so we are basically first there will be the power of 1, right? Then 2, then 3, then 4. We are skipping 5, right? So yeah, basically here I will be ranging from 0 to 4, but here we are doing the power of I plus 1. So basically this power will be from 1 to 5, right? So basically array to the power 1, array to the power 2, array to the power 3. So here from here we are basically calculating the 5 moment. Okay. So the 5 moment is calculated. Got it, everyone? Now, once we have calculated the 5 moment, it is time for us to calculate the parameters, the 4 parameters, R, K, theta, and sigma. So this is the equation, right? So this part of code is basically a code to, find the value of R, K, theta, and sigma. If you directly find it, it will be difficult for you because, you know, uh, in Python, you have to minimize the function. So basically, you can use this code directly, or you can just copy the equation to ChatGPT, and it will give you a code to evaluate what is the optimum value of R, K, theta, and sigma. So basically, we have calculated it up to you know uh, six round digits. So now here once but there is an important factor that basically this is an objective function. So this is our objective function, right? So our objective function is to minimize, our objective is to minimize this function. When will this function be minimized? This function will get minimized when mu1. So this is our moment that we have calculated, and this will, this will be equal to target mu1. So what is target mu1? Target mu1 is the moment that we have calculated, and mu1 is basically 1 plus r. So when will this function be minimized? When all these individual term will be equal to 0. So basically when our mu1 will be equal to target mu1. Got it? We have included two constraint as well. First constraint is uh, the first constraint. Can anyone tell what is the first constraint? It is basically sigma square is greater than 0. Okay, so basically you want the variance to be positive. And can anyone tell what is the second constraint? Can anyone in the
Is
meeting
it
tell what is the
Fedor's
second
condition?
constraint? Yeah,
Fedor's
Fallot's condition.
condition.
Very good. Yes. So the second condition is Fallot's condition, right? So based on this objective function, so this is the objective function that you want to minimize. If this objective function becomes 0, then you will be able to find the exact solution of this fourth equation. Otherwise, this won't be close to 0. Basically, you won't be able to find the perfect solution, but your solution will be as close to reality as possible. Okay, so initial case is 1 1 1 1. So basically you need to give an initial guess, and then it is a numerical optimization. You know what is numerical optimization, right? It basically tries to optimize the solution by minimizing the objective function. Okay, so initially the objective function will have some value, then the initial guess will be edited a bit, so it might become 0.3 0.2, so it will be edited a bit, then again objective function will be calculated, and on that objective function similarly we try to improve our case, and based on this, when the objective function reaches a minimum threshold, we stop, and then we reach a solution. So basically we see the optimum values, right? K is equal to this one, r is equal to this one, sigma is equal to this one, and theta equal to this one. Okay, so this is how you calculate the uh, parameters. This is the calibration technique. Okay, so this is one of the technique. This is the method of moment. Similarly, you can use other technique to find out the parameter. Okay, got it, everyone? In the meeting, anyone having any doubt? Hello? Anyone having any doubt?
No, sir.
Okay, very good. Then we have to calculate the characteristic function, right, which appears in the Heston model. By the way, I have one complaint from you all. So you all remain quite inactive in the group project. Only few of you were active. So when you see the Heston characteristic function, is this equation correct? Can anyone tell? Is the call price function correct? Anyone? So if I show you, rather I will show you directly over here. So this is the call price. Okay. This is the call price from Heston model. Okay. So you see, basically there is a mistake. The mistake is obviously the ST should be outside. Okay. So this ST should be outside from here. So you know, I didn't pay some heed to it, and I have written it into lecture as well. So the ST should be outside. Okay. They have made some mistake. ST should be outside, and then it would be 1 by 2 plus e to the power minus RT minus T, everything then would be inside. So anyway, I will provide the link to this function. So this is the correct call formula. Okay. And so this is the correct call formula. And we have to implement this call function, right? And this call function, this F1 and F2 is the characteristic price. Okay. So characteristic function. Okay. So if you see, uh, just a minute. So if you see, they have, try to make it simple for you. They have, so that the call price will be just this one. Okay. So the call price, they have, so I will share this link basically to you. So this call price they have made simple, quite simple for you to implement. So this is the basic call price that is there. If you want to find, if you want to see how it is there, you can check it in the Jupyter notebook. So basically this is the call price that we have to implement, right? And now, when you try to write this function, using integration. So basically, when you integrate from 0 to np dot infinity, basically you would get a limit exceeded error in the Python. So that is why we don't go to infinity. We go to a optimum number of iteration that may be regarded as infinity. Okay. So this is the call price that we have implemented. Okay. In our you know so this is the characteristic function. I hope you don't have any problem with the characteristic function. So how to, write the equation for the characteristic function? Just remember that I is complex over there. Okay, I5 in I is complex. So you have to write as I equal to complex of 0, 1. And then they will, use I as a complex, complex notation. Okay. So regarding the characteristic function, it is very easy to, find its Python code. You can just paste it to ChatGPT, you can get the Python code of characteristic function. Okay. Otherwise, you can see it is very easy. You just have to do basic np dot square root row sigma multiplications, everything else. Okay. So basically, characteristic function take this many input. Got it? Can anyone tell what is VT? Rho everyone knows, sigma no, theta kappa What is VT?
Volatility.
Volatility or volatility. Okay. So VT is basically volatility at time t. Okay. Everyone got it? So, I and Ashish, when we were discussing it, so when you implement the project yourself, you faced various kind of issue. So we were not able to, calibrate the model. So VT, so when you will face some difficulty, so VT is the current volatility, okay? So you don't annualize it. So this will be equal to daily volatility that you get, okay? So it won't be the, so you don't have to annualize it, okay? So we have a, an inner feeling that whenever you get volatility, you just multiply it with root under 252, right? So then you get the annualized volatility. But VT is the current volatility, so you don't have to analyze. Annual volatility means what is the volatility, what is the observed volatility after 1 year, but VT is the current volatility, so you don't have to multiply it by root 52. Okay, and then we define the Heston call price. Okay, so it is very easy. You just have to see the function that I have just shown you. Okay, so this is the call price that we are implementing. So you can see this call price will be very much easy for you to, because see here the numerator is f into s minus I, so f is just the characteristic function, right? So you, in the characteristic function you have to put s minus I, right? So you can see in the, so this is the first characteristic function, so basically you are putting 2j plus 1 divided by 2, and the second characteristic function you are just putting s minus I, right? Got it? And then you just put, so this is the numerator. Numerator is characteristic function simply. And this is the second numerator. So this is the first numerator, f into s minus I. And this is the second numerator, basically f into f of s, right? What is s over here? What is s? S is basically phi that we were dealing. Okay. So s is basically phi of characteristic function. Okay. Got it? So you just see this is the numerator of the first domain. So this is the this numerator and this is the second numerator. Okay. So this is the second numerator and this is the first numerator, but they have interchanged it. And then this is the denominator part. Okay. So this is just very easy to implement if you see it by yourself, line by line. So when you see this equation and when you see this code, you will be able to understand it in detail. What is the call price? Okay. So once you get the call price, you can put everything. So basically, you can get everything. What is tau? Can anyone tell? What is tau? What is tau?
Time
Time to
to
maturity.
maturity.
Yes, time to maturity. Very good. Okay. And R is, risk annualized risk-free rate of return. So you have to, so you have to get the annualized data, right? And similarly, this time sigma is the volatility of, so sigma is the annualized volatility. So you have to annualize it. So basically whatever sigma that you get from method of movement, so you basically annualize it over here. Okay. And then you put, and basically you get the final Heston call price. Got it? So this is it. If you have any doubt, you can ask. I have, tried to show you the code. Basically, the code is very easy if you see this thing over here and here. So I have explained each line. So if you have any issue over anywhere, and if you have any doubt, you can ask me. Otherwise, I will move on to the resume section. Any doubt? So if I just repeat it, what is, what we are doing. So basically, we started with, how is Heston, what, like, why do we need Heston model? So why was Heston model formed when we had black source? So the reason was that, black source model assumed that volatility is constant across all maturity date and, you know, for all calls, for all maturity date and for all timed expiry, right? So then what, sorry, the Black-Scholes model assumed that the volatility is constant for all strike price and similarly for all maturity date, right? But we don't observe it. So when you plot the volatility, so when you plot volatility on any axis, so basically let's say volatility is plotted on Z axis, and on X and Y axis you have a strike price and time to maturity, you don't get a flat curve. Okay. So basically what you get is, a surface. So a surface that you can see is, so volatility is basically changing for different strike price and for different time to maturity. So volatility is not constant. So that was the basic assumption of Black-Scholes. So then we needed something which, which, can give the representation, the simulation of the volatility. So Heston came up with a model, and the basic intuition of that model was derived from the three factors. The first factor was that the volatility, in general, when you see the volatility for 10-year or 20-year, it kind of follows a mean reverting process. Okay. Apart from that, he also observed that the volatility was random. So from there, he got the intuition to, model volatility as a stochastic process. Okay. Apart from that, he got, so you see the volatility and the stock price is kind of correlated with each other. Okay. So that is why he gave two stochastic process, one for the stock and one for the, so one for the stock price and second one for volatility. Both are the stochastic process. Volatility follows the mean reverting process because it is observed that volatility is mean reverting in nature. Okay, and both the stochastic processes are correlated with each other. Okay, why are they correlated? Why did Heston choose to correlate those two stock price to correlate those two stochastic process? Because stock price and volatility are in general correlated. Okay, so that is how Heston came up with this model. Okay, then we saw the derivation, like how do we derive the Heston price. Okay, so we see various mathematical tools that are used, basically Radon-Nikodym derivative, and then we have Grishano theorem and all. Measure change we have used. So we reach up to a point where we need to derive what is the probability of a stock, what is the probability that the a stock price at expiry will be greater than K, that is a strike price, under the measure S and under the measure Q. Okay, and from there we left in the lecture, right? So I will share you the derivation from there, and then we observe the call price. So the call price in the research paper was a bit wrong. I did pay attention to it. You can see this any other call price formula. There was just based change of expression. So basically, when you see it, this ST should be outside, and then 1/2 plus all this thing will should be inside bracket, just like K into something like this. Okay, so there was just a small error in this call price. Okay, then after once we have divided the call described the call price, we observe that call price is a function which is the characteristic function. What is characteristic function? Characteristic function for a random variable x is defined as expectation of e to the power I phi x. Okay, where phi is just an random constant. So now we go on to the code part. In the code part, we first have to find the parameters. How do you find the parameters? You find the parameters using method of moment. Okay. What is method of moment? We calculate the moment of Q, basically first moment, second moment, third moment, fourth moment, and fifth moment of Q. We can get the moment from historical data. So basically we can get the moment of Q from the historical data. So we have these 5 moments. Now we also observe that these 5 moments are functions of K, R, theta, and basically sigma as well. Okay, rho doesn't come there, so basically we omit one of the equation, that is the third. We basically omit the third equation. So basically we have first equation, second equation, fourth and fifth equation. From these four equations we calculate the value of K, R, sigma and theta. Okay, so this is the calibration technique. So basically you find the what is the you know what are the data that that is fitting the model. Okay, so please remember that this formula, the formula for mu1, the formula for mu2, that is this moment, is coming from Heston model itself, and that is why it is called calibration, because this formula is coming from Heston model itself, and then we are fitting the historical data into that model to find out the value of these four parameters. That is why it is called calibration. Okay, so from calibration, we find the value of these four functions, and then we just implement. We write the Python code for characteristic function. We write the Python code for uh, call price. Writing the call price is very easy. So once you observe it, you can just see when you observe the characteristic function and you observe this, you know, uh, this code, it will be very much easy. So you will find M and AC, right? So it will be very much easy for you to visualize what is how this code is written. Okay. Similarly, this Heston call price will be very much easy if you see this call price. So I will share this blog link, okay, to you. So after this, everything is quite easy. You just put the parameters and then you evaluate the call price. That is very much easy. Okay. So any doubt? Anyone? Anyone? Any doubt? Okay. So I request you to use a different stock, okay, and a different time period. Change some parameters, change the value of variables if needed, so that this code looks like yours, okay, so that you can show it in your resume, okay, and understand each and every line. And if you have any doubt, ask it in the group before 23rd of June, okay. And prepare a basic documentation. So in the documentation, you may explain the basic intuition behind Heston model, write the equation, explain all the steps, and add the pseudocode and add the GitHub link of your basically code and share it to me by 23rd. Okay, got it, everyone? So this is the documentation part. Okay, coming on to the resume. So when you will be writing it in your resume, so write it something like this: calculated the so implemented the Heston model. So derived the equation and then implemented the Heston model. Used calibration technique like method of moment. maximum likelihood estimation method of least square to estimate the parameters. Okay, so like this, you have to write it in your resume. Okay, so please mention the word calibration. This is very important. Okay, they don't expect freshers to know calibration technique. Yeah, that is it from my
Uh,
side. If you have any question, let me know.
Sir, for the calibration, should we use Maple or should we use Python for calibration?
Don't please don't use Maple because the data here is so so small that you already know, right? You are trying to use Maple. So in Python, we are not directly finding the equation. So basically, we are using some kind of numerical optimization. Okay. So what we are doing? Okay. So
Okay, sure, sir.
let us just let me just brief it what we are doing. So basically, we are trying to frame an optimization function. Okay. So let us just suppose that mu1 is 1 plus r. So you know mu1, right? So just a minute. Give me a time. Yeah. So this 1 plus r is our mu1. Okay. Let it be. And the first moment that we find, let it be target mu1. Okay. So what we do, similarly, this will be our mu2. And the second moment that we find out from historical, it is target mu2. And then we write an objective function. What is our objective function? Just a minute. So we write an objective function something like mu1 minus target mu1 square plus mu2 minus target mu2 square plus mu4 minus target mu4 square plus mu5 minus target mu5 square. Suppose that the mu1 that we get by calculating 1 plus r is equal to target mu1, then this will be 0, right? This one will be 0, right? If if 1 plus r become exactly equal to the target mu1, right? Guys, this equation will
Yes,
become
yes,
0.
yes.
Yes. Similarly, this one will become 0, this one will become 0, this one will become 0. When this 1 plus r will be exactly equal to the moment that the first moment that we calculate from historical return. Similarly, this minus, so this thing will be exactly equal to the target mu2 when the moment that we calculate from historical return is exactly equal to r plus 1 square plus theta. So that is why we write this objective function. So this objective function will be 0 only when mu1 is equal to target mu1, mu2 equal to target mu2, mu4 equal to target mu4, and mu5 equal to target mu5. So this is our objective function. We want to minimize this objective function. We want to, we want to make this objective function 0. So exactly 0 won't be possible because some equations don't have any solution, right? So that is why we want to make it 0, make it as close to 0 as possible. Okay. So we want to calculate that value of r, k, theta, and sigma, which can give the minimum value of this function. Okay. Got it?
Yes,
Got
sir,
it,
got it.
everyone? And given we have two constraints, so we have already written the constraint. Okay, so that is how you solve this problem. So that is why I don't recommend use Maple, use Python only. But you can show it in your a resume that you have used Maple. That is not a problem. So you can do it from Maple as well. But there is no need. Maple is quite easy to use. But the data here, you won't get accurate data from Maple. Rather than use numerical optimization. So you can show that you use numerical optim. So after calibration, you can also write that you use numerical optimization to calibrate the model. So you mentioned the numerical optimization part as well. Okay. So they may ask question that what is numerical optimization, but I guess you will be able to explain. Numerical optimization is like you have an objective function. So you either want to maximize the objective function or you want to minimize the objective function based on some constraint. Okay. What are the constraint over here? The constraint here is that this volatility square should be greater than 0, and the second constraint is the Fowler's condition should be satisfied. Okay. But so these are the two constraints, and you have an objective function to minimize. So based on this, your code gives you the accurate value of r, k, theta, and sigma. Got it, everyone?
Yes, sir. Also, sir, for the
Yeah.
document that we have to,
Anyone need out?
sir, the document that we have to make,
Okay,
it
Akhil.
includes.
So basically, yeah,
Yeah, can
yeah,
you
is it
please share
possible?
any can you please share any reference material, like what type of document we have to make?
So
Reference.
see the research paper that we are trying to use, right? See, this is a research paper that we are trying to use. So this is the same type of document that you have to make, but you don't have to make it in so detail. So basically, first you will be writing the Heston's formula. So first you will be starting with the what was the problem with black holes. Then you would be writing Here the first is introduction. So here you can write the criticism of black holes. Okay. In the second equation, you in the second part you can write what is, so what is the intuition behind Heston model. You can mention those three things that I have written in the lecture, right? Then you can write this equation. So basically the two equations that is there. Explain all the parameters like this. Okay. After that, you write the Heston model's call price. So please make sure that you write the correct call price. Please use latex. Okay. So you can directly copy. So there are several extensions available that can help you write in latex easily. Okay. So you write the correct call price. You explain what is characteristic function. You write the correct characteristic function. Okay. So this is the correct, this characteristic function equation is correct. Okay. After that, you mention how are you basically estimating the parameters. Okay. So explain the steps, basically method of movement. Then you can basically this is the step, and then you can basically end that there by conclusion. So basically you can show your result, how close your result is with accurate data. That's it. Okay. Yeah, basically you have to write pseudocode as well. Or if you don't want to write pseudocode, you can just attach the GitHub link of your code. That's it.
So, sir, got it. And should we also delve deeper
Yeah.
into a derivation of Heston model, call price and all?
No, don't derive. No need to derive. No need to derive.
Okay, sure. And
Yeah.
it's an individual document, right? So we have to prepare it
Yeah, it is an
individually.
individual. Yes, because I want this project to be individual for everyone. Guys, I have the code is already shared by us. So please refer to the last code. Please try to understand it. The code is very easy to understand. Okay. And after you understand the code, try to use it for a different stock. Try to change the, name of the variable so that this look your code. Okay. So basically plagiarism should not be there, because suppose that you two are applying in the same company for internship, so it may become difficult for you, so try to change certain things. Okay, got it.
Yes, sir, got it.
Yeah, anyone having any doubt? Yeah, so basically this was it from my side. I hope I have justified the promise that I made when this project had started. So any complaint, anything from anyone, because I tried my best. I feel, according to me, I feel I have tried my best. But if you have any suggestion, you can give.
Hi, sir. I have a question. Am I audible?
Yes. Yes, you are audible.
Yeah, so, while like putting something in the resume, especially a project, it really helps if it has some numerics. So can we do any further work in this particular project, which is more relevant to a real world problem? Like I understand this is a real world problem only, but can we further extend it to get some numerics? Like this is like the impact that this created.
Okay, so regarding the impact part, what you can do, you can, try to see the analysis that so your calibration, how, useful your calibration. So because your calibration is different from others' calibration, right? So how you accurate your data is with the data that someone calculated from black source. How you accurate your data is with the data that is present in the market. Okay. So that is the thing that you can show it in the impact side. So basically, that is what analysis means basically. So you can continue this project to do the analysis in the Heston model. Okay.
Okay, so we can basically compare the results from Black-Scholes and Heston model, and that
Yeah,
can be
exactly,
like the
exactly.
okay. Okay.
For example, apart from that, you can also use other calibration techniques. Okay, you can use other calibration techniques, and you can see if you were able to find anything. If you're able to get some more closer to the a real result. Okay. So basically,
Yeah.
it depends on how, basically, if you are able to come up with a new calibration technique. So that is also the real world project. So basically, they try to find out some other calibration technique. Okay, got it? So
Okay.
these are the some
Yeah.
things that you
Thank
can,
you.
that is, yes. Any other
Yeah.
doubt from anyone? No? Okay, then please review the code. Please review the research paper. I hope, this project has made a significant impact, or basically you have understood something. That was it from my side. Thanks a lot. You have been, quite uh so basically active, and so it was a great experience for me as well, guiding you all. Okay. Yeah, thanks everyone.
Thank you.
Thank you.
Okay, so let us, so if you are enrolled in the project 2, we can meet there. I guess many of you are from the cohort as well. So we are regularly discussing, not an issue. Okay, then, bye.